Good morning, everybody. And the first thing I'd like to talk to you about is mutual inductance. So I've got a little diagram here and a few little equations written down. So let's go over exactly what's going on. So the black loop is our first coil or current loop that has N1 turns, a current I1 going through it, a magnetic field B1. The blue loop is our second coil, and it has some flux going through it due to loop 1, and we'll call that phi B2. Since there is a flux going through it, we could say that there's a electromotive force E2 in the blue loop equal to N2 times delta phi B over delta T. And this gives us our very simple Faraday's law for a loop with N turns. The other thing that's maybe a little harder to see is this relationship. So the flux going through loop 2 would be into phi b2. And it's got to be proportional to I1. So the current going through the first loop. And that's because the current going through the first loop tells me the magnetic field, and the magnetic field gives me the flux. And then that constant of proportionality that makes it an equality is this M21, where the mutual inductance in coil 2 due to the magnetic field generated by coil 1. And that's what mutual inductance is in this case. It is the response in a second coil due to the conditions in a first coil. And I can combine these two relationships, and I can say, well, that means N2, I can do delta phi B delta T is going to be equal to, well, let's say the mutual inductance is a constant, and then I get delta I 1 delta T. And this tells me that the EMF in the second coil is equal to this mutual inductance constant times the rate of change of the current in the first coil. Similarly, E1 would be the mutual inductance in 1 due to 2 times delta I2 over delta T.